Imagine this. You drop your pencil and it always falls straight down. You throw a ball forward and it always moves in one straight line. But how does nature know where the object should go and how fast should it move? Welcome to the simplest and most powerful idea in physics: motion in one dimension. This is the Learning Studio, where we teach every subject with clarity, stories, and science. Let's crack this topic in just a few minutes. Think of a straight road. One line, forward and backward. That's one-dimensional motion, moving along a single direction. Now, three words matter here. One, displacement. This is not how much you walked. It's how far you are from where you started. Example, you walk 10 steps forward, displacement equal plus 10. You walk 10 steps back, displacement equals 0, because you return to your starting point. Easy, right? 2, velocity. Velocity means how fast you move and in which direction. Walking fast forward, positive velocity. Walking fast backward, negative velocity. Standing still, velocity equals 0. Velocity is basically the attitude of your movement. 3, acceleration. Acceleration means your speed is changing, not constant, either speeding up or slowing down. Your dad presses the car accelerator, speed increases, acceleration. Your dad hits the brakes, speed decreases, negative acceleration. You sit still, acceleration equals 0. And now, the magic piece. The three superstar equations of motion. You don't need to memorize them blindly. Just understand why they exist. When you move in a straight line and acceleration stays constant, like gravity, nature follows three simple rules. V equals U plus at, final speed equals starting speed plus acceleration time. S equals ut plus half at squared, distance equals starting speed times acceleration pushing it forward. V squared equals u plus 2as, final speed squared depends on acceleration and distance. These equations tell you everything about how something falls, moves, speeds up, or slows down. If you drop an apple, if a car speeds up, if a ball rolls on the road, these three laws describe all of it. Now think about this. If one-dimensional motion is so simple, what happens when we move in 2 dimensions? What changes when we throw a ball up and forward instead of straight? Why does it follow a curved path? That's where motion gets beautiful. And we'll explore that in the next lesson. This is the Learning Studio, making complex subjects feel simple. Hit subscribe if you want the entire physics series explained like this. See you in the next video, where motion becomes a whole new story.